Hello everyone. In this tutorial, I'd like to show you how to build an RDF ontology and store it in a local knowledge graph environment. I will use Apache Jena as a triple store and Apache Fuseki as a Spark endpoint. And most of the data will be imported from Wikidata. On my previous video, I showed how to query data from Wikidata and merge it with locally stored data. This time, we will first design an RDF-based ontology that defines all the classes and properties required to build a validated set of data. The topic remains the same, artists, mainly painters and sculptors, and the museums where their paintings and sculptures can be found. So the first step is to design the ontology. You could design it with a text editor using the TTL format, but it's much easier to use a tool such as Protege or Top-Break Composer to do so. So Protege is the tool I'm going to demonstrate today. So let's have a look. This is my Protege environment. Here I define the different classes used in my ontology. So I have some artists. An artist is a person. An artist can be an actor, a book author, a music composer, a musician, a painter, and a sculptor. So these are all definitions that I created myself. And an artist can be found in a museum. We have a museum can be found in a city, in a continent, in a country. And we have also artistic movements, so impressionist, expressionist, etc. We have artifacts such as paintings, sculptures, books, buildings for architects, and so forth. And we have the art period. So these are the classes. So a painter can have some attributes. Here I create RDFS label painter in English and peintre in French. I also said that a painter is a creator of only painting. And so you can add many other information like that. Let's just add a new type of artist, which is a ceramicist. So Picasso, for instance, is also creating ceramic. So I'm going to say add a new class, person ceramicist. And as you can see, I typed here person as a prefix, and automatically you get this http www.art.org ontology person and ceramist at the end. So where is this prefix coming from? Actually, this is coming from here, ontology prefixes. Some prefixes are already created, predefined, like RDF, RDFS, so that's W3C prefixes or OWL. And the other prefix like movement, like painting, like person, this is something that I created myself. And everything I create myself, I just start with art.org ontology and then /person, /movement, /museum, and so forth. If I go to city here, I see city is part of the world prefix. If I go to museum here, an art museum is with a prefix museum and so forth. So you can make a very nice distinction between the different type of classes and even the individual of these classes. It makes it a bit more readable and it avoids conflicts with IDs if you use numbers as IDs. Then we have object properties. Object properties are relation between objects, between instances of classes. We call that also individuals. So exposed in, for instance, is between an artist and a museum. An artist is exposed in a museum. Is city of is the city of a country, and the opposite, the inverse property is has city, and has city is between the country and the city. Then we have the data properties. So here we have data types such as date. Here, a person has a date of birth, has a date of death of type timestamp. Painting has a height and a width, type decimal, and so forth. So once you have created your ontology, and by the way, this is a very important step because this is really defining how your data are going to look like. And you must take some time creating the proper ontology. Otherwise, you will lose a lot of time later on if this is not done properly. So once you have done that, you save it, and you can also look in Eclipse. So I'm using Eclipse for my complete set of data. And here is my art ontology detail. And as you can see, it's a TTL file that is generated in the background for whatever you add in Protege. So your triple store will just upload these triples in a very simple way because it's TTL. Okay, so let's go just one comment about my ontology and Wikidata. So we want to extract as many information from Wikidata and import that in our ontology. The problem with Wikidata is it can sometimes be very tricky because anybody can add information in Wikidata and not always in a very consistent way. Trivial questions such as extract a list of museums and their location, city and country can be sometimes very difficult to solve. I'm just taking an example here. Leipzig, a city of Germany, has an ID Q566661. I'm looking which city is this museum. So we have actually this, it's not Leipzig, it's a museum. Huh? We can open it. So here is our museum. And here is the information located in the administrative territorial entity. And we have Centrum. Centrum is the center of the city, but it doesn't tell me which city. You find it in location, Leipzig. Back to another museum, Basel, Kunstmuseum. There, if I look at located in the administrative territorial entity, I find not Centrum, but Baselstadt, which is the center of Basel. I'm not really interested in that. I have no information about location, but Basel as a city exists in under capital. It's not a capital. Another example of inconsistency is Gauguin is a painter. This is the ID. He's defined as an impressionist. He's not an impressionist. He's a post-impressionist. That's okay. That's the way I see it. So I have to modify that. Another example is Moore. It's another painter. This one has two entries for the birth date and the death date. That's not possible. So we have an inconsistency here. So you need to do some cleanup before you start doing the import. Another remark, Wikidata is using this special service syntax to on their own Spark endpoint. You cannot use that syntax with Jena or Fuseki. So let me illustrate that. So I'm going to Wikidata here. and I'm opening a Spark endpoint. Here's a Spark endpoint. Let's execute it. And the Spark query here is asking me for a few artistic movements. So I just predefined the IDs of the movements. And as you can see here, I use the service syntax of Wikidata, which makes it very easy to extract the label and the description of any variable defined in this select statement. So the variable movement, just by adding label uppercase for L and description, will give me directly the description and the label. Here it's in French. You can have it in English if you want to. Here we go. And the same thing in English. Without this service syntax works well also. It's a bit more complicated because you have to add this line here, optional RDFS label, name one, filter French. But here I can have French and English on the same line, as you can see. So that's the way we are going to import the data into our triple store. Now, importing means transforming the data structure of Wikidata into our own data structure that matches with what we just created in the ontology. And to do so, we cannot use a select, but we need to use a construct. Let me show you that on Wikidata. Here is a construct. And the construct statement here transforms the data from Wikidata into something that would work in our own ontology. So I have a set of triples generated with this construct, and that is fine for us. We can directly use it to consume in our triple store. Unfortunately, we don't have any download option here for triples, only CSV and HTML whatsoever. The good news is the same construct statement works on Apache Jena. So let me show you that. I used exactly the same with one little difference. I'm executing that here. Table, huh? So I had to add this line. Of course, my Spark endpoint points to per default to my local data. But if I want to point to an external Spark endpoint, I have to give this service an URI to point to another Spark endpoint, which is Wikidata in our case. And we get exactly the same, same information. And this time I can save it as turtle, as triples. And this is under response. So here I have the triples. And we could save it. But I don't want to have triples. I want to have a turtle format, as mentioned here. So a little bug here. We have to go here, say triple, back to turtle, execute again, and it's fine. I get now the turtle format. And as you can see now, you can download it. Download the result. I can open it. And I have my 1, 2, 3, 4, 5 new movements that I could add to the existing movement I already have in my triple store. Okay, so that's step number 1, how to extract data and how to transform the data. Now we are going to import, as an example, a set of painters, 4 new painters. Before I do that, let me explain my art world database in Jena. So I can go to edit, list current graph, and I see that my triple store has already some triples. So I did exactly the same way as I showed here, a few constructs on Wikidata, and I imported cities, countries, museums. I imported 7 painters already, and I imported the ontology, and the last one is movements. In the triple store to have something a bit more consistent than just 0 triples and then upload a few persons. Okay, but what I did, I did a split of the graph. Instead of having everything in one single graph, I partitioned this graph into subgraphs. So we call that named graphs. So there is one that is not a named graph, the default graph. This is usually what you do. And in this default graph, I stored the information about artists, and that's it. In the world name graph, information about cities, countries, and in the artifact name graph, information about paintings. Here the museums, information about museums. Here the ontology we just created in Protege. And the last one is movement. So the movement information we try to import before in this name graph. So this has an advantage. Whenever you add new movements or new persons, you don't have to drop the complete ontology and reload a new set. You just can say, I want to just drop default and reload default, and that's it, without disturbing the others. This is much easier to do than having one default graph where you do a bunch of updates, which is nothing else than an insert, delete statement on many triples. So if you talk about billions of triples, this is going to be very slow if you do some single inserts of triples, and it will be extremely easy to handle when you do a truncate and reload of just a name graph. If I go to movement and I look at the data, you can do that here. You will see that these are basically only information about the artistic movements stored in my triple store. Okay, so let's load some new artists in my triple store. Before, let me check what we have already. So this is a select statement that tells me how many painters we have in this triple store. And so we have 11. And I would like to import some new persons, some new painters. Huh? So I'm going to do that here with this import statement. And so construct is here, where, and then I give a list of persons that I would like to import. So let's say I want another painter, such as Bacon, huh? Francis Bacon. Okay, so I'm taking this ID here. And I'm just adding Bacon to my list. WD. Here we are. And then let's run. Okay, so we have now a few painters, and we have bacon is also here. Okay. Then we say, as before, response. We have to do that little trick here, turtle, and get the turtle file, export this turtle file, upload it into my file, whatever comes back. So here we are, download the result, open it. I'm taking these new painters here, all the way down, down, down. And I'm going to my TTL file, person. And at the end, I'm just adding the new people that I created. So we have Michelangelo, we have Bacon, we have Vermeer, and so forth. We might also as well add some new information, such as Giacometti is a sculptor, he's not only a painter. So this is something that I defined myself. And I can go to a second file, person2, and just add this information into here. And once I'm done, I just go here and say load art world. And now I have 1219 triples in the default graph instead of 1200 before, because I added Bacon and some other painters. Okay. After you've done, you're done with that, you need to check for missing movement. So you have a Sparkle query to do. We have to generate the missing movement and add it to the triple store. And then we have to add the relation between painters and museums, and the relation between painters and paintings, and then from paintings to museums. So we have, for every step, we have a Sparkle query to do so. And what I did now with Fuseki, you can also do the same way using Jena, a Java class. Huh? So I just created a very small example on how to do that. So this Java class create person is using my construct query from before here, and is storing it into a file. So the file, let me just delete some of these files just to be sure we don't have, we have all data. And I'm going just to run create person. So run configuration, create person is here. I'm going to add an argument, which is the two person I would like to create. So you can, with a comma, add some more artists if you want to. So let's keep that as it is. It's going to Wikidata. It's getting the triples from Wikidata, and it's storing it into this person 221116.nt. So let's have a look. Data is here. Refresh. And now we have the new data for this two person that we just requested on Wikidata. And the same way you can do that with museums, with cities, with countries, and so forth. And you can program the whole thing into some Java classes. Okay, so last thing, I uploaded also exactly the same data set. I mean, this data set here into another type of triple store. This one is commercial and it's called Allegograph from France. So altogether we have 84,000 triples stored in this triple store. And let me show you a few features of this triple store. So we have the painters and movement. Exactly the same query as in Fuseki. So all the queries in Fuseki, of course, will work the same way in Aerograph. It's all compatible. What you can do here is you can also say, show me the long parts. So here are the Wikidata information and here are the person information. Let me see, Impressionism movement. I see that I have 4 painters belonging to that Impressionist movement. These are the paintings that are exposed in this museum, and the museum name is Finnish National Gallery. So as you can see, you can drill down in your data and have a better understanding of your triple store. The other thing that it can become very handy is the graphical viewer of Aerograph. Let me give you an example. I'm taking Paris. As a city. I'm taking Impressionism. As a movement. I'm requesting all the relation between a direct relation is part of movement is a direct relation. In art period is one. And I can see that in my triple store, I have 1, 2, 3, 4 painters belonging to the Impressionist movement. And Impressionism is part of the 19th century movements. Let's go to Paris. In city is city of. So here are the museums that can be found in my triple store for Paris, and Paris is in France. So now I can ask, give me for Monet the path between, let's take all the different options, Claude Monet and Paris. And as you can see now, Monet can be found in this museum, this one, and this one, but not in these 3 museums. What you can do also is add a select statement. So let me go back to that one, queries. I prepared one for the graph. That's the one. And with W, you switch to Sparkly queries. I run the query, and these are the list of all the museums in Switzerland, found in my triple store, of course. Huh? And I can add now the result of this Sparkle into my graph. So now I have all the museums in Switzerland. I could again ask between the link, give me the link node between Monet and Switzerland, and it will tell me in which museum a Monet can be found. As you can see, the graph becomes a little bit uneasy to read. This is a very small graph. As soon as you start adding or drilling through a huge set of data, this might not be the best solution to look at your data. But at least it's helping in some cases understand a little bit the structure of your ontology. So I'm not saying that Jena or Fuseki is not good. I'm just saying that this type of commercial tool comes very handy and can be very easy to use. It has also Java APIs, very similar to Jena APIs. So you could use both. That's it for today. Thank you. Bye bye.